Mathematics of chemistry. What is a mole? Today we're going to be talking about counting in chemistry. What is a mole? Avogadro's number, as you can see an image of Avogadro right here. Measuring by mass, and some worked examples. Counting in chemistry. Chemistry is the study of matter, and matter is counted in three different ways: by counting, by mass, and by volume. Knowing how the count, mass, and volume are related allows us to convert among these units. In chemistry, instead of measuring with a dozen, we will measure with a mole, which is abbreviated MOL. What is a mole? Well, let's talk about what's not a mole. A mole isn't a little bump on your skin. It's not an undercover agent. And it's not a furry little animal with a long snout and really scary long claws. Instead, a mole, abbreviated MOL, is formally defined as the number of carbon atoms in 12.011 grams of carbon. The mole is basically a representation of a given amount of atoms that make up the average atomic mass of carbon. In 1 mole of carbon, there are 6.02 times 10 to the 23rd atoms, which happen to have a mass of 12.011 grams. In a mole of helium, there is still 6.02 times 10 to the 23rd atoms, which happen to have a mass of 4.00260 grams. Why is there a difference in mass, though? I thought they had the same number of atoms in 1 mole. Well, it is true that each sample has the same number of atoms, but the mass of each atom, as we know from atomic structure, in the sample is different based on the number of protons and neutrons that each individual atom contains. In each atom of carbon, there are 6 protons and 6 neutrons, which make up an atomic mass of 12 atomic mass units. In each atom of helium, there are 2 protons and 2 neutrons, which makes up a mass of 4 atomic mass units. So the number of things in 1 mole of a substance is always 6.02 times 10 to the 23rd. So 1 mole will always represent 6.02 times 10 to the 23rd. 1 mole of any element is always 6.02 times 10 to the 23rd atoms. 1 mole of a covalent compound will be 6.02 times 10 to the 23rd molecules. 1 mole of an ionic compound is 6.02 times 10 to the 23rd formula units, and 1 mole of ions will be 6.02 times 10 to the 23rd ions. So in this image down here, we have a balloon filled with helium representing 1 mole of helium, a graduated cylinder of water representing a mole of water, a mole of copper, a mole of aluminum, salt, as in sodium chloride of course, and sugar, which the chemical name of sugar is sucrose. Here's another way of looking at it. I have a substance, a particle, a symbolic form, and particles in 1 mole. If I wanted to represent atomic nitrogen, I'd be talking about an atom with a symbol of N, and in 1 mole, I'd have 6.02 times 10 to the 23rd nitrogen atoms. Nitrogen gas, which we know is a diatomic, would be considered a molecule, representation N2, and in 1 mole of diatomic nitrogen, there would be 6.02 times 10 to the 23rd molecules. Water is a molecule with a formula of H2O, and 1 mole of water would have 6.02 times 10 to the 23rd molecules of water. A calcium ion, well, that's an ion with a symbolic form of Ca+2, and in 1 mole of calcium ions, I would have 6.02 times 10 to the 23rd ions. Calcium fluoride, which is represented as a formula unit because it's an ionic compound, which formula is CaF2, has 6.02 times 10 to the 23rd formula units in 1 mole. And finally, just like we saw, sucrose is a molecule with a chemical formula of C12H22O11, and in 1 mole of sucrose, we'd have 6.02 times 10 to the 23rd molecules. Measuring by mass, otherwise known as molar mass, the mass of 1 mole. 1 mole has a mass equal to the gram formula mass, which we'll call GFM, or molar mass of an atom, a compound, a molecule, or an ion. The molar mass is the mass in grams of 1 mole of the substance. Remember, if we're talking about 1 mole, we're talking about 6.02 times 10 to the 23rd particles. Methane consists of molecules each containing 1 carbon atom and 4 hydrogen atoms, and the chemical formula for methane is CH4. How can we calculate the mass of 1 mole of methane? Well, 1 mole of CH4 molecules consists of 1 mole of carbon atoms and 4 moles of hydrogen atoms. And you might say, well, how do you know that? Because we have subscripts here with an assumed 1 by the carbon, so that represents 1 carbon, 1 mole of carbon, and a 4 right here, which represents 4 hydrogens or 4 moles of hydrogens. The mass of 1 mole of methane can be found by summing the masses of the carbon and the hydrogen atoms present. So the mass of 1 mole of carbon times the atomic mass of carbon, which is 12, equals 12. The mass of 4 moles of hydrogen, well, you have 4 hydrogens times the atomic mass, which is 1 gram. 4 times 1 gives me 4. 12 plus 4 gives me 16. So the mass of 1 mole of methane molecules is equal to 16 grams. Let's look at an example. Find the gram formula mass of sodium hydroxide. Well, we know the formula for sodium hydroxide is NaOH. So I'm going to have NaONH. When I look at this formula, I can see that I have 1 Na, and the atomic mass of sodium is 23. So 1 times 23 is 23 grams. I have 1 oxygen, so 1 times 16, because the atomic mass is 16, so that's going to be 16 grams. And then I have 1 hydrogen, so 1 hydrogen times 1 gram, because that's the atomic mass of hydrogen, is equal to 1 gram of hydrogen. And if I add these up, 23 plus 16 plus 1, I get a total of 40 grams per 1 mole of sodium hydroxide. And that is how you determine gram formula mass. Let's look at some other examples. Find the gram molecular mass of water. Now in this case, we can say molecular mass because we know that water is a molecule. I could not say gram molecular mass with something like sodium hydroxide because that is an ionic compound. So we know that the formula for water is H2O. The most important thing that you need to do is make sure that you write the correct formula. That is key. Then I'm going to list my elements. I have hydrogen and oxygen involved here. A couple of equal signs. So I look at my subscripts. I have 2 moles of hydrogen, each with an atomic mass of 1 gram. So that's going to give me 2 grams. I have 1 oxygen here. 1 oxygen times the atomic mass of 16 grams. So 1 times 16 is 16 grams. And then I'm going to add them together. So 2 plus 16 gives me 18 grams per 1 mole of water. So that is the gram molecular mass or molar mass of water. Find the gram formula mass of copper 2 sulfate. So we know that the formula for copper 2 sulfate is CuSO4. Now a little reminder, how do we find that? Well, we know that SO4 is going to be minus 2 because that's on table E of our reference tables. Since the name states copper 2 sulfate, we know it must be Cu plus 2 because that Roman numeral tells us what the charge is on the copper. So now that I know that I have the correct formula, I can line my elements up. So Cu, S, and oxygen. If I look at my formula, I know that I have 1 copper with an atomic mass of 64. For sulfur, I have 1 sulfur times an atomic mass of 32 grams. So 1 times 32 is 32. And for oxygen, I know that I have 4 oxygens, each with an atomic mass of 16. So 4 times 16 is 64 grams. So when I add these all up, I'm going to get 160 grams per mole. For the last one, we have dinitrogen pentoxide. So N2O5. So I'm going to write out my atoms here. So I have nitrogen and oxygen involved. When I look at my formula, I see that I have 2 nitrogens times 14, which is the atomic mass. So 2 times 14 is 28 grams. For oxygen, I have 5 oxygens times 16. So 5 times 16 is 80. So when I add these both together, I'm going to get 108 grams per mole of N2O5. So now you have 3 different examples of how to find gram formula mass. So what did you learn? We talked about counting in chemistry, what is a mole and what's not a mole, Avogadro's number, measuring by mass, and then we did some worked examples at the end. Need more help? Feel free to contact me. Have a great day.